Hello, everyone, and welcome. Hope you're all doing very well. For those who were in our previous webinar, I apologize. You're gonna have to listen to me as I kind of reel off these housekeeping notes again. Maybe this is a good time to run out and just grab a quick coffee. So first of all, thank you so much for joining us. Just a few quick points. We're gonna be doing a live Q&A at the end of the webinar. So please feel free to submit questions via the questions dropdown in the GoToWebinar panel, and you can submit these at any time throughout the webinar. We'll try to get to as many as possible within the hour. If we don't get to your question in the hour time limit, we will follow up with an email. All questions will be addressed anonymously. Quick disclaimer, all information discussed in this webinar is for education purposes only and should not be applied directly to the administration of any particular file or claim. This webinar is being recorded and we'll post it on our website, LinkedIn, and YouTube. So please feel free to pass them on to your colleagues or use them in team meetings. We'll be sending everyone a completion certificate following the webinar. And at the end of the webinar, when you press the close GoToWebinar window, you will be prompted to answer a few quick questions, and we would really appreciate your feedback. So if you do have time, please fill out the survey. At any point, if you're experiencing difficulties, you can email webinar@origin-and-cause.com, or you can just submit a question via the question dropdown. Okay, Nabi, if I could just get you to, thank you very much. So our topic today is slip and falls on stairs. And our speaker is Nabi Gooderzi. Nabi is a professional engineer in Ontario, Alberta, and Atlantic Canada. He has over 10 years of professional practice. He investigates damaged and under-designed structures and also provides recommendations for their repair. And he conducts structural investigations on industrial and commercial buildings as well. So without further ado, I'm going to hand things over to Nabi. Please take it away.
Thank you, Mark. Good afternoon, everyone. Let's get started. So today we're going to talk about stairs. In this presentation, first, I will talk about slip and fall insurance claims. I'll give some statistics on that for Canada and US. And we'll talk about who is responsible for stair fall. We'll give the anatomy of stairs and introduce some terms there. We'll briefly talk about building codes in Canada and how they are set up. We'll talk about design principles for stairs in Canada. And then we'll delve into Ontario Building Code requirements for rectangular stairs and also for spiral stairs. We will then talk about safety requirements for stairs in Ontario Building Code. And we will talk about historical changes in OBC requirements. Then we'll give some concluding remarks. So now let's look at some statistics about slip and fall on stairs. In US, fall on stairs is the second most common cause of accidental death after car accidents. In British Columbia, about 8% of hospitalizations were due to stair-related injuries, based on the BC Injury Research and Prevention Unit, published in 2017. The same report said the cost of hospitalizations was over $17 million during 2013 and 2014 fiscal year. The societal economic cost of stair-related accidents in Canada was $19.8 billion in 2004, according to Public Health Agency of Canada. Societal economic cost is the sum of medical cost, loss of productivity, and loss of quality of life. So you can see that there's a huge impact on the quality of life and lives, and also on the economy. There's a huge impact by slip and fall accidents. Now let's see who is responsible for a stair fall. In terms of hierarchy, first is the designer. The designer should always design the stairs based on the building code of the jurisdiction. In Ontario, it's Ontario Building Code. In Alberta, for example, it's Alberta Building Code. Then the contractor is responsible to follow the design drawings and build the stairs according to the design and the drawings. Then the owner is also responsible to maintain the stair to keep meeting the requirements of the building code. And the stair user should also use the stair as it's intended to be used. Now, for example, let's say a stair is perfectly designed and the contractor didn't follow the drawings and didn't install the handrails properly. That's the contractor's responsibility. Or let's say the stair is designed properly and the contractors built it correctly, but for some reason the owner decided to paint the stairs in such a manner that it's kind of invisible. So if you can see here on your left, the stairs cannot be distinguished. So if someone slips or trip over these steps, that's the owner's responsibility. We will talk about these later in this presentation. Before we delve into the requirements of the steps, let's take a look at the anatomy of the stair. In this schematic, you can see a stair. This is the flight of stair. This is the floor level. You climb up the stair, you come up to a landing. You have handrails. You have extension of the handrail at the top and bottom of the handrail. We'll talk about that. You have the ceiling above the stair, and you have the stair width. The stair width should be enough for people to climb up and down. If I take a look at a step is, it has a vertical element and a horizontal element. The vertical element is called the riser, and the vertical dimension of a step is called the rise. The horizontal dimension is called the run. And sometimes you have a projection of the runner beyond the adjacent step. This projection is called nosing. Then we have a dimension called tread depth. So tread depth is equals run plus nosing. So when it comes to handrail, the handrail, sometimes you have a wall beside the stair, and then you have the handrail right beside the wall. There should be a clear distance between the handrail and the wall. Otherwise, when you try to grab the handrail, you hit the wall and you cannot grab the handrail when you lose balance. The handrails also, they have some railing. The railing, there should be spaced far enough. They should be spaced close enough so that people don't fall out. We will talk about these later in the presentation. Now, when it comes to the stair types, the Canadian Building Code defines 3 classes of stairs: rectangular stairs, angled stairs, and winders. So for angled stairs, you can see that the treads are not, they're not of uniform width. They are trapezoidal to make a turn, to make a kind of spiral shape. And then winders, the tread edges, they are concentric. So the treads are, some of the treads are triangular. Now, let's take a look at the building codes in Canada. In Canada, we have National Building Code of Canada, which is just a model code, and it does not have legal status. It was first published in 1941, and it's been updated since then every 5 years on average. The latest edition is 2015. Provinces and jurisdictions in Canada adopt or amend the National Building Code, and then it becomes a legal document. In Ontario, for example, we've adopted on National Building Code, and we changed it a bit, and then we have, and now we have Ontario Building Code. The same way other provinces do the same way. In Nova Scotia, for example, they just exactly adopt the National Building Code with maybe some minor changes here and there. In Ontario, as I said, we have Ontario Building Code. It was first published in 1975, and the latest edition is Ontario Building Code 2012, which is OBC 2012. This is now the legal document in Ontario. In every province, as I said, they have their own building code, which is kind of based on National Building Code of Canada. Now, let's take a look at the design principles of stairs before we get into the details. When you look at the requirements of the Ontario Building Code and in general Canadian building codes, there are two classes of requirements for stairs. The first class is based on ergonomics, which is to ensure that an average healthy person should be able to use stairs without difficulty. And I should stress an average healthy person. So if someone has some physical disability or some cognitive disability, or someone is so senior that they cannot use the stairs, then those people need special assistance. And so average healthy person should be able to use stairs without difficulty. So the stairs should not be so steep that you feel tired when you get up the stairs, or it should not be so deep that you take very wide strides to walk up the stairs. In other words, the stairs should kind of, walking on the stairs should kind of match your natural stride. So examples of these requirements are reasonable range of rise and run of stairs. As I said, it should not be so deep, should not be so steep. The second class of requirements is to ensure that the risk of falling is minimized. Examples of these requirements are having non-slip treads, having uniform run and rise so you don't trip over a step, and having a reachable and graspable handrail by the sides of the stairs. Now, I'm going to give you an example of a situation where these requirements are not met. This is a stair flight to a subway station in Sunset Park, New York. Someone took photos of the people tripping over a step on this flight, on this stair flight, and it went viral on the internet. Apparently, there was one of the steps at the top of the stair flight that a lot of people would trip over. So it went viral, and somebody investigated, and they found that there's half-inch difference between one of the step and the adjacent steps at the top of the stair flight. Now, when you think about half-inch difference, you can't really see it. So I'm showing the section of the stair. One of these steps is half-inch higher than the other, but you cannot really see it visually. Here it is. So this stair has all uniform rise. This stair flight, one of the rises is half-inch higher. So a small difference can make a safety hazard. Now, I should mention that in any stair flight, when you take the first few steps, your brain automatically calculates the dimensions of the steps, and after that, your brain automatically adjusts your stride, so you don't need to individually measure or look at the steps to adjust your stride. It's your brain adjusts your strides based on pre-calculated dimensions of the step that your brain calculated based on the very few steps that you took. Now, if along the way one step is odd, then you'll trip over it because it doesn't match the calculations. So it's very important to have uniform steps with the right size and dimensions. Now, let's take a look at some of the OBC requirements for rectangular stairs. As I said, rectangular stairs, they have uniform width along the step. So width of stairs in residential buildings should be 36-inch minimum. The stairs that are serving single dwelling units, which are single family houses, should be minimum 34-inch wide. Stairs in non-residential buildings should be minimum 36-inch wide or 5/16 of an inch per person based on occupant load limits specified by Ontario Building Code. Ontario Building Code has a long table which gives the minimum area per person for that specific type of building. For example, for classrooms, it says there should be minimum 19.991 square feet per person in a classroom. In a school shop or vocational room, it should be 100 square feet per person. Now, based on these, technically, you can calculate what is the maximum number of people who are allowed to use a specific building based on the Ontario Building Code. Let's take a look at an example. Let's say on a floor, you have 5 classrooms. Each classroom is 1,000 square feet. In total, you have 5,000 square feet classroom space. So 5,000 divided by 1991, 251 person maximum are allowed to use that space, that floor space. That's the maximum number of people allowed to use that space based on the Ontario Building Code. And based on this number, 251 times 5/16 inch is 6 feet 6 inch width of stairs. So the stairs to that floor need to have minimum 6 feet 6 inch width. Okay. Now, height of stairs. Obviously, the stairs should have enough headroom so that you don't bump your head to the ceiling. In Ontario Building Code, it states there should be minimum 77 inch of headroom in single dwelling units, which is single family houses, or minimum 81 inch in other buildings. And between the adjacent landings or consecutive landings, there should be maximum 12 feet height between consecutive landings. This is to avoid fatigue when you are using stairs. If it's higher than that, you get tired by the time you get up the stairs. A run and rise of steps. There should be minimum risers in dwelling units, in houses. Less than 3 risers is a tripping hazard. The dimensions are given in a table in OBC 2012. For rise, for service and mezzanines, minimum 5 inch. There's no maximum. For private buildings, houses, the rise should be between 5 inch and 8 inch. For public buildings, 5 inch and about 7 inch. Now, here I should mention that in general, the requirements for public buildings are more strict than requirements for houses. The reason is that for houses, you are very familiar with the environment of your house and the stairs in your house. But for public buildings, people are not familiar with the environment. So the requirements for public buildings are more strict. Let's get back to the table. So for rectangular treads, the run, which is the horizontal dimension of the step, should be maximum 14-inch for service and mezzanine spaces, and between 8.25-inch to 14-inch for private buildings and houses, and should be minimum 11-inch for public buildings. Tread depth, as I mentioned, tread depth is run plus nosing. Should be maximum 14-inch for service and mezzanine spaces. For houses, should be 9.25-inch to 14-inch. And for public buildings, should be minimum 11-inch. And there's no limit given for maximum. The nosing should be maximum 1 inch. We'll talk about the nosing later on in the presentation. Where you have a winder, first of all, the winder should be less than 90 degrees, and the angle treads should be between 30 to 45 degrees of angle, and the run is measured at the center of the step. So the average run should be between 6-inch and 8-inch. So uniformity of stairs. Stairs should be uniform so that you don't have to individually look at the steps to calculate what kind of stride you need to take. And as I said, that's how your brain adjusts your stride as you are walking up and down the steps. After a few steps, your brain has a pre-calculated dimensions, and then it uses that dimensions to adjust your strides as you walk up and down the stairs. The tolerance of rise and run between adjacent treads should be 3/16 of an inch. That's about 5 millimeters. And the difference between the largest and smallest run and rise is 3/8 of an inch. Should be 3/8 of an inch, which is about 10 millimeters. The slope of treads should be less than 1/50. These requirements are given graphically here. Here, AR is adjacent to rise, which is rise height plus or minus 5 millimeters, which is 3/16 of an inch. Adjacent tread, as I said, tread is the run plus nosing. Adjacent tread is tread depth plus or minus 5 millimeters. Rise height, I said, for private stairs in houses, it's between 5-inch to 8-inch. For public stairs, 5-inch to 7-inch. And the tallest riser, the difference between the tallest riser and the shortest riser should be 10 millimeters, which is 3/8 of an inch. And the difference between the deepest tread and the shallowest tread should be 10 millimeters again. We will talk about this later, but tread depth, you have the tread depth, you have the nosing. The nosing should not take away from the required tread depth by more than 15 millimeters, which is 5/8 of an inch. Handrails. Handrails, they serve to guide the stair user up and down the stair, and this is very important for people with impaired vision, and also people who are carrying bulky items. And it also provides safety for the stair user, so that if you lose balance, you hang onto the handrail to regain your balance. Having said that, if you're running up and down the stair and you're not using the handrail and you trip over a step, that's not the designer's fault, that's not the builder's fault, it's the user's fault. So if you're not using the handrail, it's your own responsibility and your liability. The minimum number of handrails within a dwelling unit for houses, minimum you need 1 handrail. For other buildings, you need 1 handrail for rectangular stairs. For spiral stairs, you need 2 handrails. And if the width of the stair is greater than 3 feet and 7 inches, again, you need 2 handrails for public buildings. If the required width of the stair is larger than 7 feet 2 inches, you need an intermediate handrail, a third handrail. I gave an example on how to calculate the minimum width of stair based on occupant load of the building. You do that calculation. If you figure that the minimum width is greater than 7 feet 2 inches, you need a third handrail. The third handrail should be positioned such that the distance between any 2 handrail should not be larger than 5 feet 4 inches. And the idea is that someone in the middle of the stair should have enough access to a handrail for safety reasons. The handrail, the height of the handrail should be between 34 inch and 38 inch. There should be extension at the top and bottom of the handrail, minimum 12 inch. This is for guiding the user to indicate so that the user knows when they arrive at the top or bottom of the handrail. Again, this is very crucial for visually impaired people or people with some disabilities or people who are carrying bulky items. The distance between the posts of the handrail should be maximum 4 feet. So this is a distance between either posts or connection of the handrail to the wall behind it. So this is a graphical representation of the requirements for the rectangular stairs. As I said, you should have handrails. They should be graspable. The shape of the handrail should not be such that it's difficult to grab it. So you should be able to grab the handrail as properly to hold on to it. We talked about the clear height of the stairs. There should be railing attached to the handrail, and the maximum opening of the railing should be 4 inch for houses. For industrial buildings, it can be 8 inch, but for houses, it should be maximum 4 inch. The handrail, if there's a wall beside the handrail, there should be minimum 2 inch clear distance between the handrail to the wall. Otherwise, when you're reaching for the handrail, you might hit the wall and you might not be able to grab the handrail when you're about to fall. The other requirement is that the handrail and its attachment should not reduce the width of the stair by more than 4 inch. So usually you have, this is the handrail and there's a piece here that attaches the handrail to the wall. So that total projection should not be more than 4 inch. Now let's take a look at the example. This is a stair to a restaurant. A restaurant patron slipped and fell while going down. We reviewed the information. Building was renovated in 1980s. At that time, OBC 1975 was in effect. We measured the stair width to be 44.5 inch wide. There was no requirement for uniformity of steps in OBC 1975. We measured it, however, we measured the run and rise of every step, and I'll show you in the next slide, but there was no requirement for that. Handrail was installed only on the ascending side, only on the right side, you can see here, which contravenes OBC 1975. Based on OBC 1975, stairs wider than 44-inch had to have 2 handrails, minimum 2 handrails. And there was only 1 handrail here. So there was only 1 handrail here, so, and the person slipped while coming down. So that was construction liability. Now let's take a look at the uniformity here. If I can show it here, yeah. So we measured the steps here. You can see the rise of every single step. So 7.5 inch, 7.5 inch, 7.38 inch, 7 inch, 7.25 inch. Now you can see here adjacent steps. There is a 1/4 inch difference, which is 4/16. The maximum allowable tolerance based on OBC 2012 is 3/16. Again, we go down here 7 inch, 7.5 inch. Again, 1/2 inch difference. So this is not acceptable based on OBC 2012. But regardless, this was built in renovated in 1980. So OBC 1975 was in effect. So this condition was not litigable. The only contravention here in this particular example was the lack of 1 handrail. Attachment of handrails. Obviously, the handrails must be attached to the wall or to the floor properly so that you don't fall when you grab onto it. Attachments of handrails should resist minimum 200 pounds concentrated load. When you are climbing, when you are using the stair and you are hanging onto the handrail, you are applying some force to the handrail. Some of it is perpendicular to the handrail. That force shouldn't, the handrail should resist 200 pounds of that kind of concentrated load. In a public building, imagine a group of people are going upstairs in a public building and they're all hanging onto the handrail. That creates a uniform or distributed load on the handrail. Now imagine that you are 5 feet away from the person in front of you and you are hanging onto the handrail and you're applying 5 pounds on the handrail. 5 pounds divided by 5 feet, 1 pound per feet, 1 pound per foot of distributed load you're applying on the handrail. Now the code says that in public buildings, handrails should resist minimum 48 pounds per foot of distributed load. So these requirements should be met. In houses, instead of meeting these requirements, you can meet these 3 requirements. These are prescriptive construction requirements for dwelling units that can be replaced for these. The attachment of handrails can be screwed to the wood blocking or stud with minimum 2 wood screws penetrating 1¼ inch into solid wood. Attachments should be spaced 4 feet maximum, and first attachment should be maximum 12 inch from the end of the handrail. This is the graphical representation of these requirements for connections of the handrails in houses. The connections maximum 4 feet apart. The very first connection to the end of the handrail maximum 12 inch. The connections should be either connected to the wall stud. I should say this first. So this is the stair section. This is the wall behind the stair. These are the wall studs. And you have the handrail that is attached to the wall. And these black circles are attachments. So these attachments should be attached to the studs with minimum 2 screws, or to a solid blocking with 2 wood screws. And the solid blocking should be attached to the wall studs. Now let's take a look at the example here. This is a single family house. A person was climbing up the stair, grabbed onto the handrail, and he lost his control, he lost his balance, grabbed onto the handrail, and the handrail broke and he fell down. Handrail, we attended the site and we noticed that the handrail was attached to drywall, not a blocking, and that is very important. I'm going to show you a sketch here. This is the wall behind the handrail. These are the wall studs. And what we found was that there was a solid wood behind the drywall in the wall cavity. So here I'm looking down in the wall cavity. This is the blocking. This is this piece, and then they attached the handrail connection to this blocking. And there was also they also patched the drywall here. So what happened in this case was the framer installed the wall and stair. Then the drywall installer did all the drywalls in the house. And then the handrail installer came in and he wanted to install the handrail connection, and he didn't find any blocking between the studs. And what he did was he cut a hole in the drywall, put a blocking in the cavity, and attached it to the drywall by some screws, and then attached the handrail connection to that blocking, and then patched up the drywall, and then that's it. But this is not enough. This does not meet the requirements of blocking as stated by the Ontario Building Code. The blocking should be attached to the wall studs. When you attach the blocking to the drywall and then the attachment of the handrail to the blocking, it means technically the drywall is carrying the force on the handrail or on the attachment. And the drywall is very flimsy to carry that load. So this is a contravention of the building code. Here, the handrail installer, when he found that there was no blocking between the studs, either he should have installed a proper blocking between the studs and then attach the connection to the blocking, or attach the connection to the stud. Because here, this is the end of the wall, you know that there's a stud here, so you could have attached this connection to this end stud. Or if you absolutely had to attach the connection to a blocking, put a proper blocking between the studs. Or don't install anything, just ask the contractor, say that there's no blocking, then the subtrade, the framer should come and install a blocking here. I'm saying this because just to emphasize that there should be coordination between the subtrades and contractor, and improvising on site can cause hazardous circumstances later on. So this is a summary of the requirements for rectangular stairs that we talked about. Nothing new here really. So 4-inch projection, we have 4-inch between the opening, maximum opening between the guards, handrail height. Now let's take a look at the spiral stairs. Spiral stairs, the run should be minimum 6-inch and average 8-inch. The flat height should be 12 feet 4-inch maximum between landings. and stair width 34-inch for dwelling units and about 35.5-inch for public buildings. When you look at the landings for rectangular stairs, you have the dimensions of the landings as shown here. So B is the width of the stair, A is the length of the landing. For individual dwelling units, which is houses, for interior stairs should be 34-inch, for exterior 36-inch, for public buildings 43-inch. If you have a stair that has a turn in it and the turn is less than 30 degrees, you still have the same dimensions. B, which is the same as width of the stair, and A, which is the length of the landing as given here. If the stair turns between 30 and 90 degrees, again, for houses, for dwelling units, you have B, which is width of the stair, and D is a dimension that I'm going to tell you how you come up with this dimension. So this imaginary line here is the walking line. WL is the walking line, which is 9-inch away from the stair end. If you draw this imaginary line, then at the turn, this length is D. That D should be 14.5-inch minimum for houses. The same dimension for public buildings should be the same as the width of the stair. Sorry, more than width of the stair. C here, which is at the end of the stair, for public buildings should be width of the stair. For houses should be 9-inch minimum. When you have 90 degrees turn or more than 90 degrees turn, the landing just has a width of B, which carries all the way along the turn. Now, safety requirements. In previous slides, I talked about strength of handrail attachments. Also, strength of stair framing and treads should meet the requirements of the Ontario Building Code. The surface of a stair should be slip resistant. There should be enough lighting for the stair. Now, having said that, if the original building and original design, it has enough lighting, but lighting is now broken, then somebody slips or trips over the step, then it's owner's liability because the owner did not maintain enough lighting in the stair. Or surface of stair. The stair might be designed properly, but if it's wet and there was no warning sign around the steps, then it's the owner's liability. Leading edge of stairs should be properly designed. I will talk about this in coming slides. Surface of stairs, as I said, should be wear resistant, slip resistant, smooth, even, and free from open defects. In public buildings, treads and landings should have slip resistant finish or slip resistant strips that extend minimum 1 millimeter above the surface. For houses, these finishes are acceptable: hardwood, vertical grain, softwood, resilient flooring, low pile carpet, matte finish, ceramic tile, concrete, and plywood for stairs going down to unfinished basement or garage. Now, steps should be visible. So the leading edges of the steps should be visible. Otherwise, the stair user cannot distinguish between the different steps, and they might trip over the step. So sloped or beveled edge improves visibility, and stairs in public buildings should have color contrast or a distinctive pattern to demarcate leading edge of treads and landings. Now let's take a look here. So this is a section of a stair. This is a step with nosing. The nosing should be maximum 1 inch. When I look at the nosing closely here, so you have run plus the nosing, and the nosing, it has a straight line and also a rounded part. The rounded part should not take away from the required thread depth by more than 5/8 inch. Here, sometimes you have nosing, sometimes you have a beveled edge. The beveled edge should not take away from the required thread depth by more than 5/8 of an inch. And that beveled edge should be maximum 1 inch. Now, having said that, again, it is possible that everything is designed properly and built properly, but if the owner put a carpet on the stair that hides the leading edges and it renders it invisible and somebody trips over this over a step, then that's owner's liability. Historical changes in OBC requirements. OBC requirements developed over years since 1975. Now let's take a look at the rise and run. Prior to 1997, no minimum rise, and then after 1997, they set minimum rise at 5 inch. Prior to 97, no maximum run. After 97, they set maximum run at 14.25 inch. Nosing, prior to 97, the nosing was 1 inch, where run was less than 10 inch, but after 97 onwards, they said nosing can be anywhere between 0 inch to 1 inch. Uniformity of stairs, before 97, there was no acceptable tolerance was given in the code. The code was just like the stairs should be uniform, but no tolerance was given. After 97, they gave the tolerances. Now let's take a look at an example here. In a shopping mall, a person slipped and fell on a spiral stair of a shopping mall. Building was built in 1997. Obviously, 1990 was in effect, and the stair was 64-inch wide. We took a look at the surveillance camera footage, and we found that the person was carrying bulky items. So that part was kind of the user's responsibility. And also the stair was wet, and there was no warning sign installed around the wet stair. So it was just recently washed. So that part was owner's responsibility. We also measured the run of the threads. The successive difference between different runs, you can see here is, I can see 12.7 millimeters. The maximum allowable run is 3/16 of an inch. And here the shallowest thread and deepest thread, the difference was about 16 millimeters. But the allowable difference between the shallowest and deepest thread is 10 millimeters. Having said that, OBC 1990 doesn't give acceptable tolerance between runs. Therefore, yes, the stair was non-uniform based on OBC 2012, but it was not litigable. So to wrap this example up, the person carrying bulky items, it was stair user's responsibility. Wet surface was owner's responsibility, and non-uniformity of stairs, it was contractor's responsibility, but it was not litigable because it was built in before 1990s. So in conclusion, stairway accidents lead to numerous serious injuries and significant financial losses. And Canadian Code key requirements address ergonomics and safety, and obviously requirements for rectangular and spiral stairs were reviewed in this presentation. Thank you for your attention. And I'm glad to take any question. Yeah.
Thank you very much. We have got a lot of questions actually to get through. So quite a few people asking, first of all, if we're going to be sending out these slides. We won't be sharing the slides, but a recording of this presentation will be made public. It'll be on our YouTube channel, website, and we'll be posting on LinkedIn as well. So you can always refer back to that. So a few more questions. Are there distinctions made between requirements for interior versus exterior stairs?
Yes, there are some distinctions between those. I guess I mentioned in some of the slides for the landing. For example, there were some differences in requirements. I believe in not run and rise. I believe in number of risers. There are also some requirements or some difference between exterior stairs and interior stairs.
Thank you. Can a distinction be made between hazards that may result in a trip versus a slip? And do these hazards apply when going up or down the stairs? Interesting.
Very good question. Distinction between a slip or trip.
Mm-hmm.
Well, there are, very good research and articles about like the statistics of like what's the probability of tripping or slipping when you're going up or going down. We didn't focus on it in this presentation, but for us, what matters is like hazard. Like, doesn't matter if you slip or trip. If the stair is not to the standard, if you fall on it, whether it's slipping or tripping or something, it's hazardous. And when something happens, when we investigate the dimensions of the stair, if it's not to the code of the time, we just mention it. And then, yeah, we just mention that it's not to the code. Now, if, for example, a good question is also that, let's say the stair is not to the code, and also it's wet, and no one put a warning sign beside the stair, and a stair user slipped on the stair, then yes, the stair, what we say is that the stair was not to the code, like let's say if it was not to the code, but the wetness of the stair is because of owner's responsibility. So we mention all these in the report, but really it's up to the judge or lawyer like to decide on it.
Okay.
I hope I answered the question. Yeah.
Yeah. If you're still unsure, for the person who asked that question, please just follow up, and we'll get back to you in an email. I'm going to kind of combine these next two questions. So the first one was, is there a number of stairs after which a handrail is required, or is it required even for one step? And then the second question said, based on what you've stated, a handrail would only be required if the total height of the stair is above 3 feet 7 inches. I was previously told that handrails were only required if there are more than 3 stairs. Is this a change?
No, that's correct. So so you need 3 risers minimum in a dwelling unit. And then if the height is less than some height, if it's like very few steps, you don't need handrail. And then Yes, yeah, read the question again.
Sorry, yeah. So is a handrail dependent of the need for a
It
handrail
depends.
dependent
Yeah,
on
it
the
depends
height
on
of
the.
the stairs or the number of stairs?
It depends, and it depends on the height.
Okay.
It depends on the height of the stairs. Yeah, if it's less than a certain height, you don't need a handrail.
Okay. Thank
The
you.
same for decks. Like if the deck is lower than some height, you don't need guardrail. For decks, we call it guardrail. Yeah.
Understood.
Yeah.
Okay. Referencing slide 37, do you mind just flipping over to 37? I think it's an image. Are there any requirements in the Ontario Building Code about vertical sections of handrails at winders? What do you think of that design in the picture?
No, not particularly at the vertical. I mean, at the winders, it doesn't particularly say it should be such and such for winders. All it says, so this is the main requirement. So no matter how you put the handrail, it should resist 200 pounds concentrated load. Okay. So this is for houses. Now, so here the handrail broke first at the top. So that was actually the first contravention because that connection, that was just one small screw. That connection first had to resist minimum 48 pound. Sorry, 200 pounds. And then after that broke, it kind of swung and broke the drywall here. Again, that connection was also not proper. So it does not necessarily say what to do at winders. The main requirement that covers all different scenarios is that no matter what the condition is, winders or straight or whatever, it has to resist 200 pounds. In houses, you can do this, solid blocking and attach it to studs. But if there's a particular condition like a winder or spiral stair, you should still take a look at these requirements and design the handrail and connections properly.
Okay, thank you.
Yeah.
Is there any code requirements for the finish on stairs in residential homes, as in can polished tile be used?
Polished tile. So specifically, Ontario Building Code gives you, yeah. So these are the ones that are specifically mentioned in the building code. So polished tile is not mentioned here. Regardless, it needs to be slip resistant. So anything other than these, you can use, except that it has to be slip resistant. So it has to have some sort of pattern or something that makes it slip resistant. So again, these are the main requirements. And it says instead of doing these requirements, you can use directly these types of finishes. If you want to use another finish that is not mentioned here, you should make sure that it meets these requirements: slip resistant, wear resistant, smooth, even, and free from open defects.
I think that's pretty clear. Okay, we're at time. We got a ton of questions still. Let's see if we can just get through a couple more quickly. Why doesn't the current building code override the previous building code requirements? For example, uniformity of stairs.
Well, because as time passes, researchers do research and take a look at the incidents, and they try to develop the codes to cover more conditions. So that's how it happens. For anything, and not for stairs, for any code, like the structural code for, we're kind of sure that for any code, as scientists, engineers, they do research and more information become available, they update the codes regularly. For
I think you
snow,
did
for
mention,
wind, for earthquake, wind, for everything. Yeah.
and I think you did mention if somebody renovates a building, then those renovations have to meet the requirements of the current building code, not when the building was originally constructed. Is that correct?
That is correct. Yeah. The renovations should meet the current building code.
Mm-hmm. Okay. What about stairs not associated with buildings, for instance, on public or private walkways, in parks, in parking lots, between aprons?
Yeah, so those stairs are not covered in Part 9 of the building code. Yeah, those are not covered by Part 9.
All right, yeah, we've got a lot of questions still, but we are past our time. So,
well, feel free to send us emails, and we'll be glad to reply all the questions.
Yes, for anyone whose questions we didn't get to, we will be replying in an email. And if a question does occur to you that you didn't think to ask during the presentation, yeah, please feel free to email us, and we'll answer that as well. Yeah, with that, Nabi, thank you so much for your presentation, and everyone who attended, thank you for your time. Have a great afternoon / evening. Okay, take care.
Thank you, everyone.